And welcome everybody to another one of the Siemens SINUMERIK webinars. Today we're going to get the opportunity to see what we like to call the total process chain of manufacturing. So maybe not the total, because there certainly are some pieces of it, but here we're going to really take a look at the programming side through our NX software solution package. Then we're going to get a chance to see some data management functionality through our Team Center product. From there, it's going to get pushed down into my world, which I get to be the lucky machine shop producing the parts today. So we're going to get to see a part programmed, run all the way through to the manufacturing process, and we are actually going to cut a live demo. So we're going to get a chance to fire up our camera feeds and see this demonstration on action. But before we get to the reason why you're here, we certainly like to get a chance to go through a few things. I want to introduce myself, certainly to those of you that may not know me or be familiar with me. My name is Chris Pollock. I'm the Virtual Technical Application Center Manager for the SINUMERIK product line for Siemens. So I am here as a product specialist on the SINUMERIK control, the SINUMERIK CNCs. And I am here as a resource to you guys. So for sure, if you have any questions, need any assistance, maybe you just need help navigating this giant world of Siemens, we are a relatively large company. By all means, feel free to reach out to me. Certainly phone, email usually works the best, and I'd be happy to help you out. And I know a lot of you have certainly taken advantage of it, and I welcome it. It's great to see all of my friends out there reaching out, and all the areas of the world we've been reaching to, for sure. Up and coming, I always certainly like to plug this program and give you a little teaser of what's coming up. So in May, we are going to do a segment on advanced turning cycles and G-code. This is building on a previous segment we did quite some time ago from the shop turn side of the world. So this is going to be going into some of the higher level functions available for you in the program guide G-code side of the control platform. So that is going to be another joint webinar produced by myself and my colleague Daniel Vitullo. So certainly if you can make it, take a look for that. And what I also would like to put out to you guys is certainly if you have any ideas about additional content moving forward, I would love to hear from you. So my email address is there, you had it before, but if you have any thoughts, whether it be webinars, YouTube live videos, a lot of you are probably familiar that I do that, or maybe you're not, we do YouTube live videos, little mini videos. What content interests you, send it my way, and we'd be happy to add it into our program. Now, if you maybe are new to this series, you might not know about our CNC4U website. This is kind of our Siemens landing page for all things operation and programming around the SINUMERIK control. And it also is our primary website that hosts all of our webinar content. So not only do we produce this stuff live, like you're seeing here today, but we also will, save the videos and they get posted on our website. So we have a huge library of material there for you. You can certainly reference these webinars moving forward, and this would be a great spot to go to get access to those webinars. Now, in addition to the CNC4U webinar links, we also have training classes available. So we have transitioned a lot of material from what we were doing in person now to online training. So our online trainings are instructor-led, so you get to work with a live instructor as well as a class. So if that's something that interests you, by all means, check out our training link, take a look. I know I have this month, I have an advanced macro programming or variable-based programming class we're doing. So this isn't just entry-level content. We have a whole bunch of stuff. We will be putting more classes on that site as we move forward. So kind of keep an eye on that site. Check it every now and then to see what's coming up. We will hopefully get back to also providing our in-person on-site training once things relax a little bit more from the COVID perspective. Now, I did mention that I do a YouTube live segment. So for those of you that might not be familiar with it, we have our own channel, YouTube channel called Mr. CNC. On there, you can see not only a lot of the webinars like this posted, but we do a lot of content specific to just YouTube. So we do a YouTube live segment. I try to do one every couple months. We're going to certainly start to produce more in the very near future. We also do little promotional videos, how-to segments, all kinds of stuff. So if you haven't been on it, check it out. I'm sure there's plenty of material there that may interest you. And finally, if you're not aware, we have created a program we call our Virtual Product Expert. And this is a program that allows you, a user, a machine tool dealer, an OEM, whoever you are within the market segment, if you would like to get access to a product specialist, specifically from the operation and programming side of the world, you can go into our VP program. You can put a request in. These are live online meetings and demos that typically are around an hour long, and we will tailor them to your requests. So Danny Vitullo is managing this program, so his information is there. But more importantly, back to the CNC for You website. If you're interested, just go to CNC for You, hit on the CNC training, and you'll see that Virtual Product Expert link. You click on that, you can put a request right there online. We have a landing page, talks about the program a little bit, and then certainly has the link to put a request in for the event. But without further ado, I would like to welcome my colleague, Michael Mannino. Michael, say hi to the audience.
Good afternoon, all.
Perfect. So Mike is joining us from the NX side of the world. So Mike is a product expert in all things CAM from our NX portfolio. Certainly, he has been a great resource for me as I learn more and more about the NX product and start to use it. So Mike comes with us with a huge resume and a lot of years of experience inside and outside of Siemens.
Too many to remember.
Yeah, absolutely. Absolutely. So Mike is going to give us a great demo, and keep in mind what I said earlier. So we're going to try to give you the overview of the holistic solution from Siemens. So as some like to say, I know Mike likes to say this all the time, from art to part. So we're going to talk about the manufacturing using NX. We're going to talk about data management and handling using Team Center. We're going to push it down to my machine. We're going to get a chance to validate it on my end through Sinutrain, and then cut some chips. So it should be a fun event. So with that being said, Mike, I am going to move this on over to you. Give me 1 second here. All right. So you have control. And Mike, I'm going to give it to you.
Can everybody see my screen?
Not yet.
Because I didn't share it yet. I'm getting there.
There you go. And we see that beautiful shark of yours now. Looks great.
Okay, so we're going to start out by going into our Team Center, and we're going to get to Team Center not through the software itself, but through a web-based client. Using a web-based client, we do not have to install Team Center on our computer as the client. We only need to have the software installed on the server, and we just use a browser to get to it. So I'm going to log in as the CAM guy. And this is what our new active workspace looks like. From here, I can do just about everything that I can do inside of the Team Center UI itself. So if I had something to do, a project assigned to me, I would see it here. I can create a new part. I can add workflows. So right now, I'm just going to go ahead and kind of like browse for my part files I want to work on. And I'm going to go down to my fryer here, which is the machine that Chris and I've been working with. So here I have opened up a selected holes demo portion of it. What we're going to show here is how we create some of those operations inside of NX, so I don't have to program the whole part file later. So what's going to be more interesting to the CAM user is underneath our part manufacturing, under the resources, we have everything that goes into that part as a resource, all the tools. Under attachments, we we could have all sorts of PDF files or anything else that's important to the user. And down in activities, we would have where we would show our part program or work instructions or anything of that nature. So at this point, I'm simply going to come in here and say, let's go ahead and open that file inside of NX.
So I would assume this system makes it a lot easier from the IT restrictions we'd sometimes have in larger companies. Is that true?
Yes. We really don't need to install software on the everybody's computer. We just need to have a web-based client pointing to the software on the server someplace. The server could be anywhere in the world, and we would find it through the web page. So for those who have not seen NX, this is our latest version, NX 1965. We look at a part program in our Operation Navigator in 4 separate views. The program order view, this is the sequence in which the operations happen. We have our tool view. This is where we store the tools and the operations underneath the tools. To save time, I've already added the tools that we're going to be using in this presentation. The geometry view, where we store the different geometry groups that we create or part boundaries or anything like that. And then we have our methods group. Based on the method, the tool, and the geometry, we can define speeds and feeds automatically. Switch back to here for now. So if I'm doing a little evaluation on this part, I see I have a part here that has a series of holes in a pocket that needs to be machined. The holes may look like they're only 2 separate size holes, but doing a little investigation here. I'm going to switch my filtering to face only. I select, that's telling me that let's switch that to diameter, which makes more sense for us. That's a 6.35 millimeter hole. The chamfer has a minimum radius of 4.49. So here I have a 6.52 millimeter hole. Here is 6.24 millimeter hole, 4.76, and a 4.69. Now,
boy, you're not going to make this easy on me, are you? You got a lot of tools I got to set up, huh?
No, just 7, I think, right?
Yeah,
so it would be quite easy to put the wrong size drill in a hole that's not configured for it. So what we can do to avoid that is I'm going to go into our feature navigator. I'm going to come over here and say, I want to go ahead and find features in this part. I'm going to tell it to use the workpiece. Select that off, show this up. And these are the different types of features we can actually find. Bosses, corner rounds, grooves, holes. In Siemens, in NX terminology, a hole is not like we would recognize a hole. A hole is a void without a floor. So some pockets, side notches, slots. What we consider to be holes, the system considers it to be a step. A step 1 hole, that's a through hole with 1 diameter. This would be a through hole with a thread. A step 1 pocket is a blind hole with a single diameter. That's what we're going to be working with here today. I'm going to select that. Say, go ahead, go out there and find my features on this part. And it goes out there and it highlights all the features on the part that it just found that fits that criteria. Go ahead and expand this now. And here's all the features that I had found. And if I select off the list here, it shows it to me in my part. I can change my filtering here to machine feature. If I come up here and hit the machine feature, it shows it to me down in my tree here. So I get feedback both ways on my part, whether I'm working off the tree or working off the part itself. So I know I have different size holes, but I don't know how many of each size I have. I'm going to go ahead and turn on some columns here. I'm going to go configure my columns. I want to go by attributes, and you see the check marks. That's showing me everything that the system sees on these holes now. And I'm interested in the diameter. I'm going to go ahead and move that up to the list so I can see that easily. getting there. And there we go. And if I say OK to that, now it's going to tell me what my feature type is and what diameter it is. So if I hit the diameter up here, I can sort them by either ascending or descending. I kind of like from small to large. At this point, I want to be able to group these. So I select them all. I'm going to say I can either create the feature process right now or group the features. So if I want to create the feature process, I have to have a tool in the library for the feature itself that has to be able to create that feature correctly. So if I don't have that type of tool in the library, or I want to take control manually of how I want to machine these parts, which is what I want to do here, I'm just going to say, go ahead and group the features now. So here are the features that were grouped together. Now, if I go back into my geometry view, you see it has added the features underneath my workpiece. I can hover over them, and it tells me what size they are. So what I really want to do is I want to reorder these in size order and machine them that way. So 6.35, 0.7, 6.5 is my largest. So 4.7, 0.69 goes above it. 6.35 goes here. So I have my 4.69, 4.7, 6.24, 6.35, and 6.5. So what I really want to do now is I'm going to go ahead and rename these. So if somebody opens up this part in the future, they will know exactly what's going on. And I'm going to, even though we're working in a metric database here, I am going to put the inch equivalent down because that's how I work better.
I like how it auto highlights too.
I was just going to say that you can see as I select them, it highlights on the part where they are.
Yeah, it gives you that nice visual for sure.
Yeah, so if I could, right, so when I select a group, it highlights it on the part, okay? So right now I have all the holes grouped together. So all I have to do is drill that group with the correct tool. However, I have all these holes that have a chamfer on them, and each group of holes has a different size diameter chamfer. I would like to be able to drill those all in one operation without having to do much picking or thinking actually to do it. I'm going to go ahead and select my workpiece here. So any geometry I put in this workpiece now will be, so I want to go ahead and insert, I want to insert some geometry here. It should be associated to the main workpiece. I'm going to go into my hole making. I want to select whole boss geometry, and let's call this spot all holes. Once again, so if somebody opens it up 6 months down the road, they know what they're looking at. Now I'm just going to simply window around the part. And it finds all my holes. Hit the display button here, and it's showing me the actual toolpath it's going to create. And if I don't like that, I could change the sequence by either closest, shortest path, or primary direction. Primary direction would be along the X or the Y axis. I'm just going to leave it alone the way it is. I like the way the toolpath is going at that point. Say OK to that. Now I'm going to go ahead and insert an operation here. I want to do a spot drilling operation. Notice the graphics we have here. It gives you pretty good detail of what you're going to be doing. I'm going to be using my spot drill. Once again, these are the tools I predefined before. The geometry is already picked. The method is drilling. And I'm going to say all holes here, right? So now if I hit my preview button, by default, it's a spot drilling operation. It's only going to spot those holes by a default amount. And I'm going to go ahead and change the attribute that it's looking at and tell it to do the face top chamfers. When I switch to that, you'll see my preview has changed and it's going to machine that chamfer to diameter. Go ahead and generate that operation. Part's been spot drilled. And inside of NX, we don't need to create auxiliary coordinate systems to rotate the tool. You see here, my tool path is rotated around the part. The geometry will tell the tool how to index. We don't have to create other auxiliary coordinate systems to do that. We let the geometry define that. So I'm going to basically do the same thing here. I'm going to go ahead and insert an operation. I want to do a drilling operation using my correct tool. I'm going to say same thing here, 0.185D. So if somebody opens it up in the future, they'll know what they're looking at. Go ahead and simply generate that operation. Those holes are drilled. Now I'm going to take advantage of our copy and pasting. So copy, paste inside. Let's go ahead and rename this to what we're actually doing. That's going to be the 187.5 holes. Go ahead and edit that. Change the drill. 187.5 holes. What am I doing there? If I put a display there, you can see the holes that we're going to drill. Generate that. Once again, copy, paste inside, rename, edit, preview, generate that, copy, paste inside, rename, OD, edit, change it to the correct tool, review, generate, copy, paste inside, same thing, rename, make it 257D, change the tool, and generate that. So within about a minute, I have programmed and drilled each one and every one of those holes. Last thing I need to do on this part, machine the floor in the pocket there. I'm going to say create an operation. I'm going to go back into my mill planer type operations. And here are the basic operations we can do on mill planer ops. I'm going to go ahead and select one that says floor and wall. And use my 1-inch end mill, my 1/2-inch end mill in my workpiece. I want a finished mill. I'm going to hit specify my cut area. That face and that face is what I want to cut. I'm going to, and if I display that, there's my two faces I want to cut. I'm going to select automatic walls. The system will go out there and find all the walls. So those are the walls I need to be aware of. I'm going to change my cut pattern to zigzag. And I'm just going to go right to finish size, but I do want to take a finish pass on the walls. So I'm going to turn on my finish pass. I want to take one pass on the walls at 5% of the tool. I could either do a direct millimeter size or a percentage of the tool. Generate. And we've machined that. Once again, the system indexed the tool by the geometry. I did not have to create any auxiliary planes or coordinate systems. So at this point, I'm going to switch back to my program order view. Once again, these are the sequence in which they happen outside in the machine. I'm going to come up here. I'm going to do a little, let's go back to the isometric view real quick and verify my tool path. I'm going to do a 3D verification. Slow it down so everybody can see it. And this is going to be doing a volumetric material removal. Putting the right size drill in the right hole here. Letting the holes dictate the index. I'm going to stop it here, flip it over real quick. Hit the play button. And now we machine the flat in the pocket, taking a finished cut on the walls. So some of the tools we have now that we can see, validate what we've done also is I can come up over here and hit Analyze, and it's going to analyze the in-process workpiece. And I'm going to get a color graph here. Blue is giving me plus material down here. Orange is giving me where I've gouged the part. Yellow is basically zero stock, no gouges. So if you look at my part, I have all yellow, except for blue where the chamfer is, because I did not machine it in this particular operation. I can also at any point pick an operation, come down here and say, show me my 3D IPW at this point. And it'll show me exactly what it looks like now. This way I know what I have machined away and what I have not machined away.
And what does IPW mean for those of us that might not be familiar with the acronym?
In-process workpiece. My bad. I don't like to speak in acronyms myself, but I'm used to showing NX customers things like this who understand what the IPW means. My bad.
For sure. No problem. So we did have one question come in. To throw it at you real fast. So when you group the holes for the drilling op, what if the same diameter holes had different depths? Could it also be handled in one operation?
Yes. The drilling depth, that's a good point. Next time we do this, I will modify some of those holes that they are at different depths to show that. But yes, the drilling is done based on what the model is, not on input. So if the holes are varied in depth, the drills will go down into different depths. Okay.
Perfect. Yeah.
So here you can see, I selected the spot drilling. I hit 3D, show me my 3D in-process workpiece, and I can verify that I did spot drill all those holes at the correct diameter. Okay. F5 cleans up the screen. Any questions before I move on, besides that one?
No, I think we're good right now, but guys will be throwing them at us.
So I'm going to go back into my active workspace here. And now we're going to open up the part that is fully machined that Chris and I would be working on together. So if I switch to my part manufacturing, you can see here I have much more detail now in this item. So I can, if I select my, from the resource area, you see here I have a PDF file that's going to show what I am doing in this operation. If I go to attachments, I have the same PDF file there. You get a PDF file of what the blank looks like. Looking at our 3D viewer inside of Active Workspace, I can rotate, pan, zoom. I could actually do physical measurements off the part.
And again, this is all stuff I can do just from a browser. I don't have to have anything installed on my PC.
Right. Here I'm showing what the part looks like inside the indexer.
There's a good looking machine.
Show what it looks like they set up on the machine. And a PDF of how to set it up on the machine. Also, I can view my part program. And some work instructions that we generated right out of NX. Okay. I could also come over here and say where used. It's going to tell me where this item is being used in. It's actually being used in itself right here. History of the part, any relationships the part has, and any collaboration that might be done with the part with other divisions or departments. Some reporting that could be done. I have none in here. And properties of the part. Okay. Back to part manufacturing here and resource. From here, I want to open it up inside of NX. Give it a second. Loading a lot of
we got
information.
We got a lot running right now. Definitely pushing these PCs.
So here's my complete program of this part. Let me just zoom up a little bit on it. Okay. So let's go over some of the operations that we've done here. I did a floor wall, which we described in the past previous demonstration. So the floor wall is just going to come down and cut that one surface. Now, I have two choices here. I could either copy the motion around, or I can instance the motion around. If I do a copy it around, each one becomes individual. If I do an instance of it, however, it all is related back to the first operation I created. So if I do any edit on the first operation, all my instances get that edit. So if I change the speed and feed on just the first one, they will all have the speed and feed changed too. For milling this area here, I did our adaptive milling. Okay. This is going to give you a constant chip load where we use a 1.5 times diameter for depth of cut and 7 to 10% step over of cut. Very few straight line cuts. Actually, it's more of everything is being done with a radius type of cut, so there's no right and left hand turns. And the rest of the part was programmed like we showed earlier. And here's the work instructions that I've created inside of NX that I showed you just before. I come up here and I go ahead and say, let's go ahead and simulate the machine now. Now, if you look at my execution view here, you see the actual G-code program. When NX does machine simulation, we post-process the code internally first and then do the simulation of the posted G-code. We do this because the posted G-code may not always match whatever the internal CAM program might be producing without post commands. So this is more or less along the lines of how a VeriCut system would do it, where you are running the actual G-code for part simulation. I'm just going to go ahead and make it a fine read and say okay to that, turn off the visibility of the part, and hit the play button.
So at that stage, right, if I did have an issue with my post, I could potentially catch it right here and now, right?
You could catch probably all of your issues right here, including collision checking with the part and the tool and the fixturing. All that can be picked up here. I'm going to speed this up a little bit because it does take the longest part of the program is the adaptive milling. So you see we're doing a bottom up where we start at the deepest part and work our way up to the shallowest part. This way we're not wasting time cutting the same material at different depths. So right here, this is what we call pillar machining. The pillar is what's left over from doing the bottom up adaptive milling. We have two choices within our program for machining that pillar. If it's a low pillar, not that much height to it, I might choose to leave it in the adaptive milling mode. But since this pillar is kind of high, I chose to use the other option, which is the spiral helical down onto it. I do that because if you leave this in adaptive milling mode, when it gets towards almost the end of cutting off that pillar, if it's so high, it might pop off and not cut off, leaving a crater in my part, and worse yet, breaking my tool. So I'm just going to spiral down on that. And here you can see the G code flying by. We
That's
also
a lot of code.
We also have the ability of backplotting existing G code programs that you've created in the past that were not created by NX.
So I could, in theory, take programs I wrote at my control and bring them over to NX?
Yes. So we machine
cool.
we machine the pillar. Let's stop this here too. Here we're doing a floor wall operation, but here I chose to take it in steps to show, even though we're just machining the top of the part, the end mill is not going back and forth to the extents of the part. It's only clearing the part by what it needs to, because we work with a true solid, so it sees that radius there, and we do not have to go all the way to the extents of the part to clean it up.
Yeah, look at that. That'll save some time, especially on a big part.
Yep. Here we're going to do the same operation type where we're going to take a cleanup pass, 5% of the step over the tool. Spot drilling all the holes with the correct diameter. Once again, the geometry is indexing the part, not construction geometry. Milling the chamfer with the same tool saved me a little tool change time. Putting the correct drill in the correct hole. Very important that you do that.
The QC guys will appreciate it.
Let alone the customer.
Yeah, no kidding. Yeah.
That's it, the part's done.
Nice.
At this point, I'd go back into my program. I would come up here and say post-process. Since we are using a machine kit, and it is the only machine we have here, only one post-processor is available to us, the one for that specific machine. Hit OK to that. There's our G code. Okay.
Looks familiar.
From there, the work instructions I've created inside of NX, I can come up here and say work instruction publish and preview that. And it took a snapshot of how I had it arranged for the documentation. It'll push it back to where it was. So here's the work instructions that were created from within NX. Basically, description how to set it up, the PDF file of how to set it up, our operation list, our tool list, at that point, I'd be ready to release the job. I'm ready to release the job to manufacturing. So I would.
Me.
No, not yet, Chris. Hold up. So at this point, I'm done with my job. However, now we're going to use our active DNC, our Shop Floor Connect, to get this information relayed to the artisan on the shop floor. But once again, this is also a web client. There's no install on the client. The installation is on the server. It's part of Team Center. So I'm going to log in as my NC operator.
And as you're doing that, we did have a question come in from Dan, who's asking specifically what is Team Center. So if you could give up a
Team
super high
Center
level.
Team Center is our product lifecycle management software. It's our data management software. If you're familiar with other, I'm trying to think of the one from CATIA, which is Windchill, right? There are other companies that do this too.
Sure.
It's our data management software. So right now I want to get this information out to the shop floor. Well, I would be emulating the shop floor guy right now, but so I'm going to go ahead and search. I know it's going to be on my fryer. And I can use a wildcard search here. Maybe I don't know every part of it, but I know a little piece of what I'm looking for. So I'm using star, fryer, star, using a wildcard search. So here's the one file that we're working with. I'm going to go ahead and bring that in. Okay. So the way Shop Floor Connect works is I can view and send files of a lot of different types. Depending on if I have those files stored in Team Center is whether or not they're displayed here. So if I see here video, if I did not have a video attached with this file, I would not see the video here. You only get to see what you have that you can show. So if I come down here and hit that, so you go ahead, show me my video. Give it a second. You know, it's almost 300 megabytes. So here comes our video. So now the artisan on the shop floor, he sees this video. He knows exactly what he's supposed to be doing. If a pitch is worth 1,000 words, how much is this worth, a video of what he's doing? Since we've already seen this, I'm just going to head quit it now. Right? We also have 3D models that the artisan can see. I'm going to go into my embedded viewer. So here's our part that we're going to be working on. Here's the blank. Now, to you, you're seeing the same things that I created and produced as the CAM guy. But don't forget, the artisan on the shop floor, he does not get to see what the CAM guy gets to see. This is his world here. This is what he gets to see. Right, so here's my setup in the indexer. My machine setup. Okay. So again, in the viewer, our embedded viewer, I get to see exactly what I'm supposed to be machining here, or my documentation. I get the documentation, what my blank looks like. And my setup. Okay, so more work instructions. These are the work instructions that were created inside of NX. Same ones, right? Go to my G-code area. So here I have, and this is the older style of shop docs that we had. They created just text files, no graphics, just text files that we can create out of NX. And so we have the shop tool list and operation list there. My program. There's the program. At this point, I'm ready to send the packet over to machine. Send the file. It's there. Here's my machine folder, right? Here's the file we just created, the packet we just sent over. If I do properties on that, you see there's the date and time, 2:46 on today's date. At this point, I'm ready to rock and roll in the machine, and I'm going to send it back to Chris.
All right, perfect. So let's see if I got it here now. And keep in mind for the audience, Mike is not in the same even building. He's actually in a different zip code. Same state, different zip code. So let's see if this whole thing worked out.
You're not sharing.
All right, so I'm going to grab control from you now, Mike. I'm going to share my screen. All right. Very good, very good. Okay, so Mike built the program, sent it through Team Center and the Shop Floor Connect functionality, right? And what we've done is we've now networked my system, my PC, and my machine to my PC through that system. So I should have it down here on the floor. Now, certainly, I'm sure Mike's a great programmer, and I could probably just drop it in here and hit cycle start, but I may not want to do that just yet. I may want to validate what the programming department did, especially if I'm in certainly larger manufacturing facilities. My programming department may be upstairs, maybe around the other side of the world. So what are some other solutions from Siemens that's going to allow us to kind of streamline this process? And one of the things I like to use is a piece of software we refer to as Sinutrain. So what Sinutrain allows me to do is allows me to build a digital twin of my machine tool. Now, this is important because what Mike showed you was simulation built off of models of the machine. So he knew geometrically what the machine looked like, so he could do crash detection and layout and all that stuff. But what he didn't know at that point was what's the machine dynamics of the machine. How is the machine going to perform? So I'm willing to even bet you, if Mike did a cycle time analysis up in NX, there, compared to the real life cycle time and what I can do in Sinutrain, there would be some decent differences. So Sinutrain, since it's built from an archive of the system, it's going to know all that. So this was done previously, and we actually went the next step with this. We utilized a service that we provide where we can also bring in machine space models. So now I can really get a good understanding of the overall manufacturing process. So this machine, and Mike, if you don't mind, I'm actually muting your mic. I was just getting a little feedback. You can hear me. So this machine was brought in and built from full machine models. And when we staged this spatially, we actually took real geometric dimensions off the machine to make sure that we could produce as close to what's going to happen in the real world in this digitalization scenario. So I'm going to use this to kind of validate Mike's program and take a look to see if it's going to do what we need it to do. Now, keep in mind, he pushed it into a shared folder. So what we've done is I've now allowed Sinutrain to map to that folder. So normally, if you have Sinutrain or on the machine, you would see, your NC, your internal memory, maybe some extended, a USB, but you wouldn't have these side buttons. So these I mapped, and I mapped to this new network and shared drive. So I come in here, we see the Fryer CM20 folder, and now we see Mike's library of data that he sent over as his packet. Now, keep in mind, the Sinutrain, although riding on my PC, it's a full machine emulator. So it's doing everything I can do on the floor. So down here, if I haven't seen everything Mike's done, I can jump into this PDF. I can take a look at my part dimensions. Now you'd say, okay, well, he's looking at it from a PC, but the reality is I can do the same thing at the machine tool. So I can come over here, go into my program manager area, and you see this program directory button. So I mapped the same folder. So I'm working right now on the exact same folder that my Sinutrain is working on. Any updates I do in Sinutrain are immediately known by the machine. So I don't even have to start managing the same file in multiple locations. Later, we are going to run this part program directly from that folder. But back to our Sinutrain portion, I can start to go through and analyze all of the different data that was dropped down for me. I can certainly go into my layout diagram to see how I'm going to set up my part. And most importantly, we're going to look at our work instructions. Now, a lot of times when it comes to work instructions, when I want to set up my part and I want to set up my tooling, probably one of the slowest portions is how do I handle all of my tool data, right? I got to build up tools and make sure that I have the same tools existing in my machine as were programmed by Mike upstairs. So I can now start to look in my offset table and see if I have my letter D drill or my number 13. I can go through each of my tools. Now, one of the first things I'm going to notice is, all right, I was using a different naming terminology when I named my half-inch tool as opposed to what Mike called his. So what's cool here, and this is something I can do in Sinutrain or physically out at the machine. Remember, everything I'm doing here, the exact same process I can do at the machine. I can grab data even out of a PDF file. I can copy it like a tool name that I'm going to use, come on over, paste it in, and now I just updated my tool data. So quickly, using that nice setup sheet that he built, I can now build up my tool library, saving a lot of time. Now, if I build it up,
I came from the Fanuc world, and every time I see you do a presentation, I'm amazed at this controller.
It's certainly a little different, right? Cool. So I go through, I build up my tools. Obviously, I pre-built them to save us some time, but yes, I could grab my geometry out of here. If the system had known lengths and projection lengths, and that's how maybe my tool crib was going to build it, I could pull all this data, quickly copy, move it out, drop it in, and next thing you know, I'm up and rolling. Now, one of the key things that we haven't shown you yet is how well a system like NX, being under the same umbrella as us in the SINUMERIK world, right, this holistic solution by Siemens, now allows us to get optimized program data through the post-processors that are built into the system and down to the machine. So what you'll see here, this is the program that's been posted, and that is the program that was simulated, right, up in NX. Well, we have full cycle support here in the system for any of our functions, right? So let's say, for argument's sake, I'm doing a drilling cycle. And I don't happen to know the block he did it, but I'm assuming he used probably a cycle 81. Yes, he did. So all of the cycles pushed out using this optimized post through NX that's been optimized for the SINUMERIK control will be fully supported conversationally. So if I'm down on the floor, I need to make a quick adjustment on the fly. Maybe my drill hole's coming out just a little short. I don't have to remember or worry about adjusting these variables inside of this kind of cryptic G code call. I just go to the cycle call or the op that I know is the problem, open it up, and away I go. Now, again, I'm that operator. I'm down on the floor. I'm miles away, maybe hundreds of miles away from the programming department. So I'm probably going to want to start to see and get an idea of what this program is going to look like. So certainly I can go into our onboard simulation, and this is the same way it would look over at the machine. And now we can start to see all of these tool paths that Mike's been describing to us. So there's our flats that were right around apart. We go into a little adaptive milling. So this is going to be certainly very similar to what you guys are used to, just driving it from an NX posted program. And we can, roll it around, do our thing. But what I can also do is now leverage the full power of the digital twin. So here I can get to the start of my program. And what I want to do is I want to execute or run the program now in auto. I'm going to hit my execute button. And keep in mind, even here, I am running this from my networked folder. Now, this could be on this PC. Most likely, it would probably be on a server somewhere. So it might even not even be local to the Sinutrain seat. Doesn't matter. It's all mapped there. So I can jump over to execute. Now, in this case, I can bring up my simultaneous record or my real-time simulation. As long as I have the machine space model commissioned, I have this machine space button. That's what's going to give me this nice model. And you notice it's an exact match to what we had up in NX. because we built them all with the same model. So there's commonality even in the base construction. When I build these systems, these full digital twins, I'm actually using NX to port out all that data. So if we hit cycle start right now, we can now come in and really get an idea of what our tool path's going to look like, but more importantly, what our cycle time is going to look like. Now, this is an accelerated motion. The clock has been sped up. So a minute in this realm is not a minute in the real world. But the reality is the cycle time, when I look at the cycle time analysis, will be a 1-to-1. Now, there are a few areas that it's not going to know. Certainly, it's not going to know how long my tool change is. So that's probably about the largest area where I would see any discrepancies. But acceleration, deceleration, speed of my rotaries, all of that is 100% known by this digital twin. So when I come in, after I go through all my ops, I hit my M30, I'm complete, right? So if I come out of my simulation and we go into our cycle time counter, I got a 6-minute and 43-second cycle time. So as we go to the machine and rerun it, we can take a look to see how close that is, right?
Mine was 5 minutes and 20 seconds.
There's a big difference, right? So in your world, everything's perfect. It accelerates the speed immediately, instantaneous. In my world, I have some machine dynamics in play. I'm also reliant on how well the machine was optimized, right, by the builder. So could he have been more aggressive in the tuning? Very possible. All right, so 643, remember that. Certainly you'll have to forgive me if I throttle down on my first part here a little bit. But we've proved it out. We like it. It looks pretty good. Keep in mind, I'm not touching the file. I'm not putting it on a USB stick. I'm not doing anything. It's all in this shared folder. So now all we have to do is jump on over to our machine. We're at our machine, and now we're going to run our part and take a look. So let's make sure all our cameras are feeding good. Yep, everything looks happy, perfect. I'm going to turn my drives on. Now, I've pre-set up all the tools for time's sake. I didn't think you guys needed to watch me touch off a bunch of tools. So the tool library has been built. The big thing here is working off this common folder. What's nice about this scenario is, if you get into maybe ITAR facilities where you have a lot of version control issues, I never have to move the program into the machine's internal memory. It can be sitting on that external server. It can be taken away once the job's done. It can be handled all remotely. Now, again, just like we showed before, if I needed to, I could go into any one of my work instructions right at the machine, take a look at them. But for me, I'm ready. I can go edit the file if I want. It's going to look identical to what I saw just before. Or when we're ready to, we can go grab that file, hit execute. That'll put me over into auto. Once I get there, I'm going to turn my coolant on, certainly close my doors because I don't want to be splashed here. All right, cycle start. Machine's going to a safe retract. Firing up the spindle, come down. Looking good. So I'm going to put it right to 100%. We're going to start firing it up. Now, one of the things I could have done, just to show you real fast, is I could also bring in a real-time simulation. So sometimes when I get to these jobs, I got a lot of coolant flying. It's hard to really see what's happening. I do like to issue this real-time sim. So this is the same simulation you saw me use over in Sinutrain. The only difference is I don't have collision avoidance physically on this machine. So now it's just going to show me the blank. All right, get it fired back up. So here you see we can start to also see what's happening. And at any point, if I stop the machine, the simulation stops, I start, it's going to move on. This is going to give the operator a good understanding, kind of throwing it back to what he's already seen from the Sinutrain side of the world, certainly what we saw up top inside of NX. And it might get a little noisy for you guys here from my side. It looks like the camera angles look pretty good. Unfortunately, it is a little jerky. That's a WebEx limitation. Looking at maybe going to different sources moving forward. So Mike, why don't you explain a little bit, like you did before, talk about some of these toolpath strategies and maybe why you chose what you chose.
Well, I chose the adaptive milling here because it is the most efficient way of getting rid of the material. I can cut much deeper, much faster, And tool life is, since we're taking such a light chip load, the tool life is extended. We're not making any linear cuts here. Everything is basically on a curve, so we don't have any right-hand turns that really make the spindle load meter jump.
Now, what's important to start to note here is, and it might be hard for you guys to see, it's certainly a lot easier for me, but the machine itself is really accelerating, decelerating at a very smooth rate and factor. And it's not getting jerky. It's not running into any problems where it's starving from data. I know it looks a little jerky from your end as I look on the other feed. But the big thing that this is causing this behavior is the fact that we're running a high-speed cycle 832. Of course, you notice when Mike programmed it, he didn't say anything about cycle 832. So, Mike, how did it know to leverage our advanced cycles that we have in the SINUMERIK control while you were programming in NX?
That's all based on the type of method I chose and the post processor.
So basically, it's happening automatically, right?
Correct.
And just another reason where, you know, you bring all this stuff under one envelope, under one roof, and it makes things a lot easier to optimize the whole process chain.
Here,
So
here we're doing that pillar cut.
Right? There, we were cruising on that. Now we're going to do a little more traditional planer milling. So we did drop the RPM a touch, I see. Now, on the graphic side, certainly I could start to rotate and manipulate as it's running the job if I wanted to. So if you want to do that, you just go to your rotate screen. I can spin it up. I can flip it around just to change my perspective. And that's all certainly independent of while it's cutting.
Once again here,
start to see that optimized spacing operation.
Yeah, we don't go to the extent of the part, we just go past the edge of the cut. Working off a true solid.
How much time that can save, especially on like a large diameter part. A little bit of coolant hit on my cameras, not too bad.
It looks good, Chris.
I got to get some better software, so it just kills me how jerky the feed is.
Yeah, I tell you, the guy who programmed this part really knows what he's doing.
I'm telling you. It hasn't broken my machine yet, so I'm impressed. All right. Looks like we're finishing up the roughing here. Looking good so far. Now, with the Sinutrain functionality, like we showed you, nothing's stopping me from getting a jump on the next job. Everything is still separated, so that's certainly isolated. I can do concurrent programming on our controls if I wanted to. It's certainly up to you. I find the digital twin solution here kind of allows me to leave the machine, let it do what it needs to do, which, let's face it, is cutting parts. That's what's going to make us money. And then I can use the Sinutrain to get all my preparatory stuff done. So maybe Mike pushes down the next part of this assembly. We can start to prove it out here from that side and be ready. Once this thing stops running, we can get on the next job.
So now we're spot drilling all the holes at the correct diameter and milling the chamfers with the same tool, saving me a tool change.
Absolutely. Okay.
Now we're going to put the right size drill in the right hole.
That's always a good thing. You know what I like too? I liked how it was smart enough to stop the spindle before it did that retract, so it can let the spindle decelerate right there, you see, so I can get into chip and out of chip as quick as possible. Amazing how many posts I see. You'll throw it up into space, then stop everything, and you're just waiting for everything to decelerate. I'd say whoever worked on this post did a nice job.
Thank you.
You're welcome. Oh, looks like now we're into the 1/4-inch size holes or equivalent. Like I said, Mike's made me earn my keep when it came to setting up drills. We had a lot of drills on a pretty little part. And I think this might be the last one. Let's see. Nope, one more.
And once again, the system, the geometry drove the tool axis, not construction coordinate systems.
I think that is so cool, the way you can just pick some common features on all kinds of different planes. Didn't have to jump through all kinds of hoops, making new planes on each point. It was very cool. And there we go.
Really,
we got a part.
Really speeds up your programming time when you don't have to put a lot of construction geometry into your part file.
Absolutely. And there you go. I had slowed down a little bit, so we were at 6:48, 7:18, and you said in NX we were around 5 minutes. So certainly we can start to see how we can kind of, between using NX and then mimicking that with our digital twin, we can really give you some solid real data that's coming in. And certainly I would say the 20-second cycle time discrepancy I have there, 30-second, would be, that's my tool changer for sure. These carousels are great. They're rock solid, but they're not known to be the fastest things in the world. Okay, so with that being said, I think it's time to get into the Q&A portion of our presentation. So let me just transition this back here.
Hey, Chris?
Yes, sir.
Can you take the part out and show everybody?
Sure, if you want. Absolutely. Actually, you know what I'll do? Might be easier so I don't get my hands all dirty. Let me jump back to here. This was our first setup part that we did the other day because, of course, we're not crazy. We're not going to do this stuff completely live. So this is what the part looks like. So there you see our boss feature, our perimeter holes. Nice looking surface finish. It did a beautiful job. Absolutely. Looks great. Looks great. It would be a perfect little like clevis part. I know it's just something we made up for the demo, but it certainly did a good job, Mike, because I'd say it looks like a real part. All right, so let us transition back. As I mentioned before, not only am I a resource moving forward for you guys, but Michael is certainly a great resource from the NX side of the world. So I did want to give you Mike's email address again if you have any questions. I am now going to pull up our Q&A, so just bear with me. And if you guys haven't already typed it in, go into the Q&A section and you can pull up. You can type in any of the questions you have. When I switch screens, it closes all these windows on me all the time. All right. So Scott had asked, where is the instance command located versus the copy command? So I would say inside of NX. Do you want to show them or you want to just explain it real quick?
Why don't you give me screen back?
Sure, I can certainly do that. All right. Bear with me 1 second.
Yep, no worries.
All right, you should have it now.
You can see my screen?
Yes.
So if I wanted to rotate this around, let me just go ahead and turn off some visibility here so it's not as cluttered. I would object, transform, wrong one. That's right, transform. Oh, I had it right to begin with. I would use rotate about a line. Line method, I can just say pick a line or a point and vector or 2 points. I'm going to say point and vector. Specify the point. I'm just going to hit the reset button so it gets 0, 0, 0, right? Specify the vector. I can either give it a vector, type in a number, or I can just pick the arrow. I can pick that arrow there and say, now here's where, do I want to move it, copy it, or instance it? I would say instance it here, right? Angle would be 60, and I would do that 5 times, and there's the result of it. Okay, so it's on the object transform. And do I want to instance it, which means if I edit the main one, they all get the same edit. Copy is going to make it a individual, so you can edit them individually, and move is if I want to take it and actually move it to someplace else.
All right, so while you're in NX, we have more NX questions. So Pete had asked, I didn't see you select a material or speed and feeds for any of the operation. Where did those settings come from?
I just used the default speeds and feeds that were out of the box. The material themselves would be underneath the workpiece. And here's where I would tell what material I was cutting.
Gotcha. John had asked, where has this been all my working life?
Well, we've
been
around since we started out being UniApt, app programming language, back in the 60s. So we've been around for a long, long time. I'm glad you like the software, though. I think it's the best one out there.
And it looks like it was, I think it was the same. Yeah, it was the same, John. So this is exactly, screen keeps changing. It's exactly what we're trying to get to at our operation. Absolutely amazing. So certainly I would say, John, reach out to either myself or certainly Michael, and wherever we can help you get there, we would certainly love to do so. Okay, let's keep on going through. Here's a good question. So Fred's a little bit ahead of us. He said, can we see the VNCK in use? So Fred obviously knows our product line a little bit. So what I'll do is I'll say, as a teaser, we will be showing VNCK shortly. This wasn't set up with VNCK, but I do have this machine fully set up on my end inside of VNCK. And what VNCK really does is it combines all the cool stuff I showed you in Sinutrain inside of NX. So we will do that, right, Mike?
Yeah, I know Fred very well. Fred, you want to give me a call afterwards, that's fine.
Oh, if you know Fred really well, then certainly if we want to set up a demo, because I don't think you have it installed, but I certainly do, we'd be happy to show you the product offline as well. But we will certainly do an event talking about VNCK, because it is a very cool way to truly unite these two systems. Okay. Pascal had asked us, what happens when NC program file is being edited by someone externally while it is running on the real machine at the precise same time? That is a good question. So I can tell you from the SINUMERIK side, what happens when I'm running machines from external memory is we're basically taking chunks of the program and putting it into a rotary buffer. So if the edit had happened basically on a line that I've already passed, we wouldn't even know it, nor would we care. If it happened on a line that is coming up that I haven't grabbed out, then it would grab that data for sure. And if I'm within that 500 block buffer, again, that has already been transferred to the high-speed memory of the system, right? So at that point, again, I wouldn't know it if you were changing something within that line segment, because from us, our perspective, even if we're cutting it right now, it's already passed. But Mike, can you speak to maybe any protection that the Team Center side of the world might put on that? Because we haven't tried it, so I don't know what would happen.
Since we're using Shopfloor Connect to download the program to the machine, anything that you edit at that level may not be privileged or allowed to go back into Team Center. That's a customer default, whether or not you want your hand-edited program to be able to go back into Team Center or not. By default, I believe it is turned off. But if you, there's no way you're going to be able to edit inside of, if you edit the file inside of Shop Floor Connect, which you can't do, you don't have the privilege to do that. All you can do is send it into the machine. At the machine level, you can edit it, but you need privileges to send it back into Team Center. And from there, I would guess that any place would want to compare the two programs and see what the changes were, and then change the CAM program to match what the edited program was, so you could always reproduce the CAM, always reproduce a good program out of the CAM system. In my world where I came from, the CAM system was the final word. If there were edits made on the shop floor, they had to be reproduced in the CAM system and a new tape file generated.
Yeah, and I would say that's a pretty common practice. Okay, let's keep on moving on because we certainly have no shortage of questions. Jim did say, great job, guys. We appreciate the feedback, Jim. Tom, is the simultaneous record able to be set so the spindle maintains a vertical orientation? So, good question, Tom. So when I have a machine space model in play, like you saw in Sinutrain, then it will, because it's driven by the kinematic of the machine. When we are running on the machine where either I'm not showing the machine space model or it's not available, like you saw on my machine here, then no, it's always going to be rolling the tool around the part. It's just the default method we chose as far as when a milling machine. Now, what's interesting is when you get to a lathe, it's not like that. So instead of spinning the tool around the part on a lathe, we let the part spin. I think we chose this method in a mill because we never know what kinematic type we could have, right? So maybe I have a head, right? So my rotaries are up top and my tool is actually moving. Or in this case, I have a rotary down the table, then the part's physically moving. So it was probably the most universal method, but great question.
Hey, Chris,
thank you so much. Yes.
There was a flash on my screen about the last question about if we changed the program in NX. Maybe that's what he had meant. If we change the part program in NX, you have to go through the active DNC process again and take it from there and download it to the machine, if that helps.
Yeah, and my gut is if it sees that the file is being opened and edited by another piece of software, it's probably going to flag that and not even let it overwrite, would be what I would expect. I couldn't imagine it'll overwrite a file that's being actively edited. Like in my case, I was running it in Sinutrain or running it at the machine, right? Yeah. But we could certainly dig into it more. Got that one. Got that one. So Shane says, you know Shane Dennison, Mike, I have a conversation with you on Monday on your post processor for the Siemens control. So it looks like Mike needs to talk to you on Monday.
Yeah, call me on Monday, Shane.
Or Shane needs to talk to me. Perfect. Okay. Why is the NX cam done in metric when the part was obviously done in inch? So honestly, we wanted to go, Mike. It's all yours.
Everything was done in metric. Just that I happen to use standard inch size tools, but the tools are actually defined in millimeters. If I go to the end mill here, it says ½ inch, but actually it's 12.7 millimeters. Everything you see here was done in metric. I just happen to use inch size, standard inch size holes on the part.
Now, what was cool on my end, just to show you real quick. Actually, you're still sharing. I'm not going to share it. But on my end, I had my machine in inch running the metric, so I was able to set up all the tooling in inch on the machine tool and let the program go to metric. But we could have certainly done it any number of ways. There wasn't any reason why we chose.
You know, even if I was in a metric world and you didn't want a metric post, I could have always came up here and said, change my units at output to inch and okay to that. And now I would get the posted code in inches rather than in millimeters.
Exactly. Shane was asking, I think Shane is actually asking about level 3 training. Shane, I would say reach out to me directly and we can talk. A level 3 training, I think you're talking about my 5-axis training. Fortunately, it's been one of those classes I've had a hard time figuring out how to transition it to virtual, because so much of what we do are real-life examples from the setup side and the running side on the real machine. So that's one that has been kind of, unfortunately, not transitioned to virtual. But if you guys have some questions or some specific needs, reach out. I'm sure I could help you out. So this is from Michael Hitchcock. For the cycle time in NX, did Mr. Mannino have any of the information for the axis velocities, accel, decel of the machine tool, or was he using the OOTB guess numbers? Mike, I'm assuming I know your answer.
No, I had none of that information, Michael. I just used the out of the box, the OTB stuff.
Exactly. Andre said, a question, the part is designed in NX, question mark. Can I recognize holes in an imported solid?
Yes, this is in NX part file. Everything was done in NX, but if it was just a done blob, it would still see a hole as a hole, a step pocket, like the system wants to know, but yes.
Perfect. All right. This is from Todd. Please email me the link. Oh, yeah, probably for the link of the videos. Yep, everybody's going to get the recording link out once it goes live. I don't think I'll get it out end of day today, but not certainly Monday morning. How is the collision check detected before it is positioned? I'm assuming I don't know if he's asking about on the machine or in NX.
Yeah, in NX, we just we tell what pairs we want a collision check, and then give it a within reach. So if I may say the holder to the part within 2 millimeters, if you see that, flag it as a collision. It doesn't happen before motion; it happens with the motion. In my world.
Okay, we got a few more questions here. So this is from Lance. Is the simulation software at the machine standard on the 840D, or is it an add-on function? Simulation is standard within our control, and it's the same simulation engine that would work within G-code or Conversational, which is our shop mill program. I would say the only add-on that you saw, which is just a license, it doesn't require any additional software, would be the 3D portion, because the 3D triggers or allows our full 5-axis simulation to work as well. So if you don't have the 3D license, then you can look at it from a top perspective, side, front, you can flip around, but you're always looking it straight on. If you want to be able to fully articulate it like I did, you would add that 3D license. Okay. Does NX support multi-channel machines?
Absolutely.
For sure. I know a lot of multi-channel machines are programmed with NX. All right, this is from Lance again. Will Siemens make an enhancement to allow users to navigate back and forth between metric and inch on the fly? Well, really, that's what we were doing in this demonstration. So I will have to say, on some machines, I think it's referring to the machine at this point, Mike.
Okay, good.
On some machines, it's a little trickier, and it's really has nothing to do with the SINUMERIK control. Has everything to do with how the machine was commissioned. So some OEMs, some builders like to do some pretty custom stuff, and if they don't think about the inch metric scenario and validate its current state at any given point, then they can run into traps. So sometimes you will see some OEMs will say, oh, this machine has to be purchased and run in a specific unit of measure. This is not a restriction of the SINUMERIK control. My machine, I can bounce this machine between inch and metric. I had my machine in inch, it was running a metric program. I could throw it in metric, run an inch program, or I can flip my unit of measure back and forth. But it is a behavior of the machine. So if your machine does not allow that, it's most likely the way it was commissioned. And in a lot of cases, honestly, on some of these complex machines, these guys get pretty crazy with the commissioning. It's why they just said, you know what, we'll just sell it as a 1 unit measure. But that is a restriction of the OEM, not the control. Great job, guys. Oh, it's Frank. It's your boss. So you're still going to be employed another day, I think.
That's always good.
Oh, and Lance was actually talking about in CAM, not the machine. So from the metric inch scenario, are there limitations to switching back and forth in CAM?
Once
From your side, Mike?
you can't switch back and forth. However, if I want to create a tool, and I'm in metric now, right? If I want to create a 1/2 inch tool, I would say inch, 0.5, and it will convert for me. The same thing, if I'm in an inch database and I want to put metric values in, I would type in MM, open parent, the metric value, close parent, and let the system convert it for me. I cannot just go inch metric on within the session.
But now what about this? What about when I'm tapping, right? Because we run into that all the time. We want to, program the machine in inch, but we got to tap some metric holes. Can we at least do that? Can we tap in metric while we're in an inch job?
Once again, under the feed rate, you would have to type in MM, whatever the pitch is, and close the parent and make that IPR, and it would do the conversion.
Okay. So we would just convert the geometry of the taps to an inch value. That makes sense.
Right. You convert.
Okay. What else we got? Oh, it's funny. Jim said, Mike, show him retrieving a tool from the library and switching inch metric. So I think that was kind of what you were showing.
Who said that?
That came from Jim Hughes?
Well, tell him to do it.
All right, fair enough. Jim, it's on you. All right.
So if I say, wait, back up the bus. I want to create a tool from the library, right? I'm going to say drilling, twist drill, okay. Right now it's millimeters. If I hit that question mark, it says I have 479 millimeter drills defined in my library. I can switch that to inch, now say, count those, and now I have, looking at just the inch side. So if I can take any one of these tools out of the library, it's now an inch tool. However, when I do open it, it will convert it on itself to millimeters.
Well, there you go. And I think that was Dan's question as well. And Jim said exactly what I was suggesting. So Jim, you don't have to show it. Mike got beat you to it. Okay, I think we got everybody. If I missed anybody, I apologize.
Just so everybody else knows, Jim Hughes is on my team. We work together, and that's why I said for him to show it. I wasn't being nasty. I wasn't being nasty to a customer.
I think we all certainly got that. So with that being said, let me jump back before we stop. Mike, stop sharing your screen for me.
Got it. I'm not a WebEx user, so it takes me a few seconds to find everything.
No problem. I'm going to share my screen. Yep. Put me as the presenter. Oh. All right. So share screen one. Just want to jump back to our contact information. So certainly, again, thank you, everybody, for taking your time out of your busy day. We always appreciate it. I was serious. If there's information that you guys want and you want to see on these segments, reach out to me, and I'd be happy to put them in queue. Again, Mike Mannino is a great resource, as you can see, from the NX side of the world and the Team Center and our software division. So reach out to Mike, blow up his email. With that being said, Mike, thank you. This was a lot of fun. I look forward to doing it again in the future.
Great. I had a good time myself.
Great, great. So with that being said, thank you, everybody. I'm going to stop the recording here and have a great weekend.
Thank you.